So today's lesson is going to be talking about squares, and a square is a rectangle that has two congruent consecutive sides. So we talked about a rhombus yesterday being a parallelogram with two congruent consecutive sides, but today it's going to be a rectangle, so it's got to have right angles. So the properties of a square are all the properties of a parallelogram. You know all this already, that the diagonal divides into two congruent triangles. Opposite sides are both parallel and congruent. Opposite angles are congruent. Diagonals bisect each other. Consecutive angles are supplementary. You also know that all four sides are congruent, and then all four angles are going to be right angles. Diagonals, not only are they congruent, but they're also perpendicular. And then the diagonals will also bisect the angles. This is where we got that 45, 45, 90 triangle from, if you think about it from the other unit. Because if all the angles are right and the diagonals bisect the angles, that's where we derive that 45, 45, 90. So the diagonal is always going to be x radical 2. So if we start doing some math with it, if you want to use the square PQRS to find each of the values, if PT is 14, then you want to find PR. But because the diagonals bisect each other, if PT is 14, TR is 14, so PR is 28. If PQT is 45, if this guy right here is 45, and it wants you then to find TQR, and then TQR is going to be the angle on the opposite side, but again, diagonals bisect the angles. It's kind of a silly question. This has got to be 45 degrees also. If RQ is 4x minus 1, and then PQ is 20 plus x, so we've got RQ right here, and then you also have PQ right here. Well, the sides happen to be congruent, so you're going to do 4x minus 1 equals 20 plus x. Subtract x on both sides, add 1 to both sides, and then x is just going to be 7. If they want you to find the values of x and y, and they give you PT and QT, and TR and TS, it turns out that all of these inside pieces are all congruent because diagonals are congruent and the diagonals bisect each other, so all four of those pieces are congruent, halves of wholes are still equal. Then you can actually use the x's together and you could say, well, then 4x minus 8 equals 16 minus 2x. And then add 2x to both sides, add 8 to both sides, and then get x to be 4. And then for the y's, you can say 6y minus 9 equals 3y plus 9. Subtract 3y on both sides, add 9 on both sides, and then get y equals 6. So the algebra is pretty easy with the squares. If you want to try to prove that a quadrilateral is a square, you can use any one of these methods. You can prove that the quadrilateral is a rectangle in which two consecutive sides or adjacent sides are congruent. So get yourselves a rectangle that has consecutive adjacent sides the same, or prove that this quadrilateral is a rhombus and just put one right angle in there. So here's our proof. We've got ABCD is a square, and then we've got EF is perpendicular to BD. So let's see what we can do. So ABCD is square, and EF is perpendicular to BD. Well, we want to try to get BF and EF the same. So we want to get these guys the same, which means we really want to get this triangle to be isosceles. So one way we can do that is we can say, well, if we've got perpendicular line segments, we know this angle right here has to be right because perpendicular lines form right angles. So we're going to say that angle BFE is a right angle. And we know that because perpendicular lines form right angles. Well, we also know that EBF is 45 degrees. because we know that the square has 4 right angles, and the diagonals bisect those particular angles. So we could say this. We could say angle EBF equals 45 degrees. And the reason here could be is in a square, a diagonal bisects the right angle. And then we know that angle BEF has to be 45 degrees also. So then we could say angle BEF, and that's basically because the 3 angles of any triangle have to be 180 degrees. And then you can say if you want to, and this step is not necessarily necessary, but if you want, you could say that angle EBF is congruent to angle BEF, and that reason would be because of substitution. Actually, probably should put that in there, because then the reason for your last piece is then we know for sure that BF is congruent to EF, and that's because in a triangle, sides opposite congruent angles are congruent. So there you go. Make sure that that proof makes sense to you, and you should be good. So good luck on your homework.